Hi folks, my name is Sunil, and this time I bring to you a session on F1 score. In the last videos, I spoke about talking more about accuracy, precision, recall. I just want to now expand more and talk to you about F1 score. If you want to have access to that video, it's on your top right. So you can click on this, go watch that video and then come back maybe. But here I move forward with the F1 score. So let's assume you have this data set where you have 16 apples and 16 oranges. Your job is to correctly identify apples within this bunch of fruits, right? You write a model and now you're testing it. What you get is you have identified 17 fruits as apples, of which 5 are oranges and of which 12 are really apples. So the few observations are total of 32 fruits, 16 plus 16, 17 fruits identified as apple, 12 out of the 16 real apples were identified as apples, and 5 oranges were observed or identified as apples, right? So this is your observation. Based on this, what we really need to do is understand how well or how bad or how good your model is behaving, right? So in our case, the precision of this particular model is 0.705. Again, more about precision, recall, accuracy in the video. Again, look at the top right, you'll get to see the video. So the precision is out of the 17 items or fruits identified as apples, 12 were really apples. So that's how precise your model is for the class of apple. And hence your score is 0.705. It just means, or another way to look at it is, if my model tells me it is an apple, how much accurate or what is the precision at which it identifies it as an apple? So when I say, yes, it's an apple, how often am I right? Look at it that way. The next metric is recall, which is identifying of the 16 real apples that were supposed to be identified, how much or how many did the models really identify? It stands to be 12. It just means of all the yes cases that yes, it's an apple, how many did I really find? Which is about 75% of your apples were identified. If you really look at it, there are 12 apples of which there are 16 apples of which 12 you've identified. So that brings it to be 75%, 0.75, right? So now what is the real implication of this in the real world? When you're doing medical diagnosis, when you're doing evaluation or screening for cancer or diabetes or any of these other diseases that are there, what you prefer to do is you prefer to have a very high recall. It's okay to have a few false positives. It's perfectly okay, right? You don't want to miss anybody out. So hence your recall, you should have your model that focuses more on recall as opposed to just focusing a lot on precision, right? So that's your first step. Once your recall value is high, then you start figuring out how your precision can be improved by maybe taking more data items, maybe doing a little bit more feature engineering, different type of signals, etc., right? So we can go into the depth of a lot of this. But this is about recall. Now, when you look at your Face ID unlock on your phone, you don't want a stranger peeping into your phone and it accidentally getting unlocked. So it is okay for the recall to be slightly low, but your precision has to be 100%. 100% when you show your face and 100% negative when a stranger shows their face. So it's okay if the recall is slightly lower. It's okay if out of 10 times your phone doesn't recognize you like 3 out of 10 times, but it'll be so bad that your phone identifies a stranger as you and then unlocks the phone for you, right? So that's the whole balance between precision and recall. And sometimes in some use cases, you want high precision and okayish recall, but in few cases, you want an absolutely high recall because precision over a period of time with feature engineering and a bunch of other things, you can improve. Of course, even for your precision use cases where the recall is slightly lower, you can work on the model or feature engineering to improve your recall as well. But it's a fair balance. You cannot be perfectly balanced. It's impossible, right? And also, if you aim for a maximum recall, maximum precision of 1, it generally means that you've overfitted the model and it's not going to work in the real production use case. So precision recall, just a quick recap, is like a seesaw. You have to balance. When you move the decision threshold to one side, the other side usually goes down or suffers a little. And the best balance really is not a mathematical balance, is based on your use case. Like we've already seen, in case it's okay for missing a few positives, right? Which means that your phone unlock, you want it to miss a few positives, but it should never let It should never let a stranger peep into your phone and unlock. And it's okay to raise a few false alarms. It is okay to call out a few people having cancer, because then you could do a second round of screening and determine that they don't have cancer, for example. But missing a patient who has cancer and then saying, hey, sorry, this person doesn't have cancer, has a bigger implication on somebody's life and health, right? So that's about that. Now, moving over to F1 score. So let's get back into the core of what an F1 score really is. In our case, because our precision is 0.705, the precision in this case is 0.705 and the recall is 0.75. Your F1 score seems to be 0.726. So what does this really mean? Is it a mean? Is it just an average? We'll find out, right? Moving ahead. So basically, how do you calculate an F1 score? Definitely looks like an arithmetic mean, but is it? It's not actually. An arithmetic mean of both these numbers, 0.705 and 0.75 precision recall, stands to be at 0.7275, which is very close to the F1 score of 0.726. Now, because these numbers are very high in the same range, this is a good coincidence. Your arithmetic mean seems to be very close to the F1 score. But let's look at another example. Let's say your precision of the model is very high, 0.95, but the recall is 0.2. It just means out of the 10 times you ask your model to predict, it gets it right only 20% of the times. Let's look at it that way, right? This is your recall. If you look at the mean, it stands to be 0.575. Well, seems to be okay if you just compare it with the previous numbers, but is it really? No, right? You have a high precision, you have a huge scope to improve recall. So now you have to get back to the drawing board, work on this and improve it. So what do you do? How do you really find out? You calculate the F1 score, which really stands at 0.33. Why do we need a different metric compared to an arithmetic mean, right? And how do you calculate it? Basically, it's a harmonic mean. What it means is when you have a very high number and a low number, a harmonic mean will always penalize the entire mean towards the lower side, right? If you look at it in our case, here, your precision is 0.95 and your recall is 0.2. So it's penalized the F1 score to be more closer to the recall value as opposed to in the previous case, where because both precision and recall were high, your F1 score seems to be decently moderate, right? Now, again, you can go into the depth of harmonic mean, and if you want me to create another video about computing harmonic mean and the intuition behind it, happy to do this, but this is the formula. So if you just look at the mean, it doesn't work. A harmonic mean, if your precision is high, your recall is high, of course, your F1 score will be higher. If your precision is high or recall is high and the other number is low, it will always anchor itself to the lower number and you will get a real fact of it, right? You will really understand how your model behaves. So this is just running through a quick example. An F1 score is, in our case, just fitting the numbers into the formula, 2 times precision times recall, divide by precision plus recall, you get F1 to be approximately 0.33 some number, right? So this is how you compute your F1 score. If you like this, please do subscribe, please do share and also like the video. I'm happy to be making more videos. I'm going to be making more and more. So don't hesitate to put comments if you have any questions on this or if you have any specific demands, happy to do that for you. Thank you. Bye-bye.